Alright, so here's the second video on patterning and linear relations. Here in this video I'm going to show you how to go from a pattern to a table of values to an actual equation. And before we start analyzing the pattern, actually I want to just talk about the meaning of this equation y equals mx plus b. Very important. I'm just going to define each of the variables here. Y is always your dependent variable. So when we're doing these like patterns here, it's going to be the number of whatever you're calculating. So in this first example, it is the number of toothpicks used to make these hexagons. Okay, and it's always, 99% of the time, is going to be in the right column of a table of values. Occasionally I've come across it; they're switched or they're done horizontally, but most of the time it's done like this. Okay, so then if y is the dependent variable, m is your slope, x is your independent variable. In these pattern ones, that's going to mean like the term number, and then the b is your initial value, and your initial value is the value of y when x equals 0. Okay, so make sure you have that written down in your notes. You should be have a firm understanding of y, m, x, b, y equals mx plus b. All right, so now we can look at this table of this table of values, and you can see when we do this, what we're going to do actually always, we're going to start with 0, and you're going to leave 0 blank for now for the number of toothpicks, okay? Because we'll figure it out as we go along. And then we're going to write 1, 2, 3, 4, because those are the terms that we have in here. All right, and if we look at number 1, term number 1, how many toothpicks do we have? We have 1, 2, 3, 4, 5, and 6. Okay, so we write 6 toothpicks here. And if we look at number 2, now you might be tempted to say we have 12 because we had 6, and now we had another hexagon. It went up by 6, but it didn't because they shared this line in common, so all it increased by was 5. Right, and you could see that if you did that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So here for number of toothpicks, we put 11. And then for number 3, well, you should see a pattern now already. It's going up by 5, so we go up by another 5 and we get 16, and we go up by another 5 and we get 21. Now, how do we find out this imaginary value of number of toothpicks for 0? We follow the pattern. We went from 21. If we go down to 16. We go down 5 to 16, down 5 to 11, down 5 to 6, down another 5. Where do we end up? We end up at the number 1. All right, and that number is very important for us because here we have the value of y when x is equal to 0. Therefore, this is our initial value. B is equal to 1. And if we want to find the rate of change, well, we can see this is going up by 5 each time, while this is going up by 1 each time. And 5 divided by 1 is equal to 5. So we're going to write for our rate of change, 5 divided by 1, or 5. M is equal to 5. So now we've got the important elements that we need in order to create the equation that we're trying to create, the pattern rule that we're trying to create. In this case, we're going to do a capital N for the number of toothpicks, and N is equal to, what did we have for the slope? The slope is equal to 5. What did we have for the independent variable? The independent variable is the term number, small n. And then what was the initial value? It is 1. So here's our equation. N equals 5n plus 1. And if you're working with this handout, you would see that there as well. Okay, let's do the next one together. It says here, create a table of values for the pattern. And then what is the pattern rule? Again, always start here with 0 and then go up. 1, 2, 3, 4. All right. How many toothpicks do we have for number 1? We have 2. How many for number 2? We have 5. How many for number 3? Well, you should see the pattern now. It's going up by 3 each time, so we have 8. And we're going up by 3, so we get 11 for term number 4. Now we follow this pattern again. We went 11, we go down 3 to 8, we go down 3 to 5, down 3 to 2. We have to go down 3 from 2, and we get -1. This is our initial value, which is B. So B is equal to -1. What's the slope? The slope is equal to, well, this is going up by 1 each time, and this is going up by 3 each time, so the slope is equal to 3 divided by 1, which is equal to 3. So now if I write my equation, y equals mx plus b, large N for the number of toothpicks, 3 is the rate of change, small n for the independent variable, minus 1 for the initial value. All right, I'm going to do one more example with you, and then I'll let you do the last one for yourself. This should say number 4 here, of course. So it says here, examine this pattern of connected triangles using toothpicks. Again, we're counting the number of toothpicks. And so we're going to start by putting 0, 1, 2, 3, and 4. How many toothpicks did we have for term number 1? 3. And how many for this one here? 1, 2, 3, 4, 5. So 5, what's it going up by? It's going up by 2. So 7 going up by 2, 9. And if we follow the same pattern, 9, 7, 5, 3, therefore this has to be, we go 3 minus 2 and we get 1. So here's our initial value. B is equal to 1. What's our slope? 2 divided by 1. And you might be asking yourself, why do I keep doing this 1 over here on the left-hand side and then dividing it? It's because sometimes you're going to come across tables of values that don't go up by 1. And if they don't go up by 1, then you have to figure out what they go up by and divide the values, the first differences, by that number. Okay, so we'll come across those later on, but important to make sure 2 divided by 1, that's where we get our slope m from. So now we do the equation y equals mx plus b. What's our independent variable? It's n. What's our slope? Slope's 2. What's our independent variable? Small n. What's our initial value? 1. And there's your equation. There's your pattern rule. All right, I'll leave you to do question number 4 on your own. Keep in mind, question number 4 is not asking you to do toothpicks. It's asking you to calculate the number of squares. So if I just start this off for you and you guys can finish it off on your own, if you look at number 1, there's 1 square there. Okay, and finish that off and try to come up with the pattern rule on your own. If you have any questions, make sure you reach out and ask, and make sure you complete the Google form activity that comes along with this. All right, I hope you all are safe. Have a good day.